The proofs. The proofs. The proofs is in the pudding. And then there was stuff I wanted to do with you that second day. Here. Now people are flying in. Here we go. All right. Good morning, everybody. There we go. So I didn't say yet hi to Levi. Good morning, Levi. Good morning, Victor and Anthony.
Morning.
Good morning. And hi, Savannah. Glad to have you back. So, what I'd like to do today is just kind of briefly go over some of what we did last time before that break last week. And then I've got all of our questions from the mastery test available here. I want to do some with you, and then I'd like to stop at 11:30 um, to give you time to do the mastery test on your own. And if you want to ask about any questions, just tell me, show me your screen, and I can find it, and then we can do it together. And tomorrow we'll move on to the next lesson, okay? So let me hide this thing. So just to quickly review a few items, doing proofs in math basically means listing one step at a time what we know about the question, the math problem or the geometry problem. That's our statement. And then on the right, we list its reason. For the reasons, we're going to be saying things like what the a formal name of the math is that we did, like distribute or addition property of equality. If it doesn't, if you don't say addition property of equality and you just said addition, I wouldn't know what you meant. But Edmentum is going to probably have the full formal name. So pre-COVID, pre-distance learning, I would just do proofs with my classes, and we would just say addition or division or something like that. But just be prepared for Edmentum to give you the full formal name, like we see in the right here. Um, distribution. Well, I just wrote distribution, addition property of equality, or division property of equality. But you know what that means. They just mean they did division. Okay. We did a proof. Oh, yeah. We defined linear pairs and supplementary angles. Just a reminder, a pair means two things, right? So a linear pair means two angles that are forming a straight line. So that's this one on the top. ABD and DBC, they are literally forming a straight line at the bottom. So because of that, they can be called a linear pair. Good morning, Brooke. We were just reviewing a little bit of what we left off with before the break. And then I want to do some of the mastery test proofs with you guys as a group. And then at 11:30, I want to stop to let everyone have time to try the mastery test on your own. And I will be available to help with any questions. Okay, that's our plan. The next term we went over was supplementary angles. And that's two angles whose measures add up to or sum to 180. And like in my picture below, these two angles aren't adjacent. They're not sharing a line. They're not literally forming a straight line. However, because we know one is 80 and one is 100 degrees, they add up to 180. So we could call them supplementary. Then we did a proof showing that any two supplementary angles, or I got it backwards. any two linear pair angles are automatically supplementary. So we proved that when two angles form a straight line, they are adding to 180 degrees. Okay, the two other terms we learned and talked about was congruent and vertical angles. So just a reminder, congruent means two shapes or figures that are a complete match. So they're unique from each other. They're different shapes, but they match. We're going to be using a lot of congruent line segments and congruent angles. So first up, the line segments AB and CD are two different figures, right? They're two different unique figures, but because they're the same measure, you could place one on top of the other and it would match perfectly. So we say that they're congruent. AB is congruent to CD. And then we could also have congruent angles, same thing. So angle EFG is congruent to angle HIJ in this picture. They're a match because they're the same measure. And then we talked about vertical angles. Vertical in math, in our math world, means they're across from each other. So in this diagram, the two yellow marked angles and the two green marked angles, since they're across the crossing point, they're opposite each other. That means they're vertical. So they won't be touching. For instance, this angle, the yellow one on the left, angle OXM, is adjacent to OXN as in night. These two are adjacent, but they're not vertical. Those are adjacent angles. Verticals are the ones opposite or across from each other. And then we did a proof showing that all vertical angles are congruent. So now we can use that in the future. Vertical angles are congruent. Basically, opposite angles across from each other are a match for their angle measure. And then we had this stuff on Thursday before the break. We talked about transversals and then the angles made by transversals. So transversals are just a line cutting through another line. It's usually in this context where we've got two parallel lines, like my two green lines here, and then our red transversal cutting across. And then we talked about corresponding angles. Corresponding angles are the ones that are in the same position. So looking at angles 1, 2, 3, 4 on top, 5, 6, 7, 8 on the bottom, we can match up angles that are in the same position. Like angle 1, I'm going to mark it again in blue. Angle 1 is like on the top left of 1, 2, 3, and 4. And then what's in the top left below? Angle 5. Those are in the same position. So angle 1 and angle 5 are corresponding. And also, they are congruent. They're forming the exact same angle shape, angle measure. And then also, there are different ways to write a proof. So everything we've done together has been a 2-column proof, where we always list the statements and then next to it the reason. We will see some different types in Edmentum where we're supposed to do a flowchart proof, and it starts at the top usually, and it'll state the statement below each little bubble. So we see given, and then that leads to the next statement and its reason. Then they bring in another statement and reason and combine those to make step 4. So if you're doing a flowchart, you're still listing the statements and reasons, but you're just kind of doing it in like a line or a linear way. So starting from the top, it leads to what we have at the bottom. And then there's a paragraph proof where it's all just written out. It's written out the way you would just say it if we were having a conversation. So honestly, I'm not a big fan of the paragraph proof because I think it's kind of messy, and I like the 2-column proof the best because I think it's clear what we're doing and what we're trying to do listed at the bottom for the proof. Okay, so I'm going to do some examples. I'd like you guys to follow along as best you can. And if I ask for some help while I'm doing it, feel free to jump in and just answer in the chat. Or if you really want to, you can use your mic. So here's one problem from our mastery test. Given AD is equal to CF. So this length from A to D is the same measure as C to F. I'll put it below CF. Now, they're not the same line segment, right? They're made of different parts. But they're telling us that those are equal measure. And then BC is equal to DE. Change my color. So on the top here, BC is this little length is equal to DE across the way. So that's all we're given to start with. It looks to me, when I look at the picture, that all the little sections are the same, right? Like AB and BC and CD, like they're all the same length, but we can't assume that until we show it, until we prove it. So all we can start with are these ones I marked in blue and red. Those were the givens. So starting with their proof, it looks like we're just supposed to fill in one box. They just want to know the reason right here. That's the only part that's missing. So they've basically done the whole proof, but we just need to figure out what is the reason for them going from step 3 to step 4. So I'm going to just read through it, and then we're going to look and see if we can figure out what is the reason that they can do step 3 to step 4. So they started with AD equals CF given. Remember, that's our golden rule. Always start your proof with the given. And they didn't show the whole given. They just did the AD. Later on in step 5, it looks like they introduced the second part of the given. And then they stated it as given down here. And that's okay. But I would have probably just started the whole thing by listing both givens. Then step 2, they broke AD and CF into like their smaller pieces. So they said AD is equal to AB, BC, and CF. That's like, look above on my blue line. AD is AB plus BC plus CD. So they're basically saying the long blue line is the adding of these shorter blue segments in the middle. And then they did the same thing for CF. So CF is the sum of these 3 smaller sections. So they're showing that here and here. And then since AD is equal to CF, then we can say AB, BC, CD right here is equal to the other sum, because this is just AD and this second one is CF. So it's kind of like repeating step 1, but they substituted it. They didn't call it substitution. They called it transitivity. Substitution. And you know what? I might not have gone over transitivity with you guys yet. So let me show you what that means on the right. Just in case it comes up again, transitive property. What does this mean? Here's what the transitive property means. This is an example. So I'll use different letters that aren't being used in the problem, okay? If X is equal to Y, and if Y is equal to Z, then we can cut out the middleman and say, then X is equal to Z. This is called transitivity or transitive property of equality. It's basically substitution. So they're kind of interchangeable. I prefer to use substitution, but it does mean the same thing as this. We're substituting in z in for y, and it says x is equal to z. We can cut out that middleman. So you might see that come up in some of these proofs, transitive, and it just means we're um, saying that the third item is equal to the first item. If 1 is equal to 2 and 2 is equal to 3, then 1 is equal to 3. And that's what they did in step 3. Now, looking back at the proof on the left, they go from step 3 to step 4. So do me a favor, everybody, please focus on this proof in the box. Look at step 3 to step 4 and ask yourself and tell me in the chat, to the best of your ability, what's different from step 3 to step 4. Just looking at the statements, not the reasons, just the statements. Can you see anything missing or different from step 3 to step 4? Because what if we can find what's missing or different, that will be a clue as to what the reason is to go from step 3 to step 4. What I want you to practice doing with me in these classes is just talking through it, even if you're not speaking to me, even if you're just doing it in your head back at home, that's okay. Anything's better than nothing. So if we can practice finding how they went from step 3 to step 4, then we just need to put that into words, and that's basically our reason. I see 2 messages in the chat, so I'm going to go ahead and check. Oh, 3. Awesome. Good job, guys. And I appreciate you messaging me directly. I don't mean to put anyone in the spot, but I am going to pull it up to see. So 3 of you noted the same thing. So high five to Savannah and I and Tatiana for all looking at that and being willing to answer for me. Thank you guys, folks. You all said that CD is missing. Good eye. So that's what I was hoping you would see. Look from step 3 to step 4 again. A, B, A, B. BC is there, BC is there. But then CD is not there in step 4, and CD is not there in step 4 on both sides of the equal sign. So because we have this, I'm going to write it on the left or on the right side. AB plus BC plus CD, and it's equal to CD plus DE plus EF. It's missing. How do we, what's happening here is BC plus CD, and it's happening on both sides. It's being added. So what they did was the opposite of adding CD. They minused or subtracted CD from both sides like this. And we know that if it's being added and subtracted, it cancels out. If it was like 5, it would be like plus 5 on the left and plus 5 on the right, and we basically subtracted that value out. So we don't know if it's 5 or 20 or what number it is, but we do know that it's on both sides, so we can subtract it, resulting in this, what they have in step 4. So what's the reason that they used for that? Subtraction. Probably subtraction property of equality, to be formal about it. Basically, though, what we did was subtraction. We minused CD from both sides of our equal sign. And then once they have that, we have AB plus BC, DE plus EF. Now what? Now they're bringing in that second given, that BC is equal to DE. And notice that in step 4, we have both of those. Because it was given that BC and DE are the same thing, now we can substitute. Wait a minute. What are they doing? So I think they should have put in another step here, technically, and substituted in one for the other to show that like AB plus BC is equal to BC plus EF, because they're saying they're equal, they should substitute it in. So either transitive or substitute, and then you minus it, and then you're left with AB equal to EF at the very end, which is what they wanted us to prove. AB is the same as EF. Tricky, and a lot of different things to be aware of. I think most of our questions in Edmentum are just doing like one little part at a time, but let's do another one together. Okay, yeah, we should check this one out together. Okay, so forgive me, I had to kind of cut it in a weird way so we see all the parts. On the left side, this is the picture that you'll be given. And then on the top right, these are the answers. I wanted to show you all the like possible multiple choice answers that they give you. So we have this diagram. We've got 4 different lines: line S, line R, line P, and line Q. And then we've got all these angles created by those crossing lines. So this is kind of like the transitive example from last Thursday and that we reviewed today. And it says in the given, P, line P is parallel to Q. So line P and line Q are parallel, and line R is parallel to S. So we are allowed to use that and assume it. R and S are parallel, and P and Q are parallel. So we've basically got a couple different like sets of parallel lines with different transversals cutting through them. They want us to prove angle 1 and angle 14 are supplementary. So that means they add up to 180. So angle 1 is here, and angle 14 is way over here on the other side. So and then this is a what you call a flowchart proof. So it's not listed the same way, but what we see are their statements in blue, and then the reason written below it. Statement and reason. They are asking us at the very bottom, I hope you can see this, what is the next step in the proof? Choose the most logical approach. So they're not asking for like the final answer, they're asking us for what's the next step. So they start by saying angle 1 is supplementary to angle 2. Linear pair theorem. 1 and angle 2 next to it are forming a linear pair. So that means they're supplementary. Then they say angle 2 is congruent. It's kind of small, write it bigger, is congruent to angle 6. How do we know that? They're corresponding. Then they wrote this long reason here. For parallel lines cut by a transversal, corresponding angles are congruent. If you just say this, I'll know what you mean. Corresponding angles are congruent. Angle 2 is in the same position as angle 6. If we honed in on those and forgot about line S, we've got P, Q, 1, 2, 3, 4, 5, 6, 7, 8. Now we see 2 and 6 are in that same position. So therefore they're corresponding, and therefore they're congruent. Now, I'm going to change to purple so we can contrast this. So check it out. We're trying to connect angle 1 to 14. That's what's in the telling us that we're supposed to prove. We've just connected 1 to we've connected angle 2 to angle 6. And now angle 6 is actually corresponding to 14 below. They're both in that top right when we look at Q as our transversal. So now we're looking at like we don't need line P. Cross it out. We're really focusing on R and S are the two parallels. And now 6 and 14 are the correspondings. So I think we can say next that angle 6 is congruent to angle 14. Why? They're corresponding angles. For parallel lines cut by a transversal, corresponding angles are congruent. Corresponding angles. And I see that is one of the options above. Why would I want to do that? Well, look where we're going. We're trying to show that angle 1 and angle 14 are supplementary, meaning they add to 180. And we've already shown in these 3 steps that angle 1 is supplementary to 2. So angle 1 plus angle 2 is 180. And then we said angle 2 is congruent to angle 6. They gave us that one in step 2. So we could substitute that in. And they haven't done that yet. But we could, and we could say angle 1 plus angle 6 is equal to 180. But then they connected angle 6 to 14. Angle 6, or I guess we did that. Angle 6 is congruent to angle 14. So check that out. Now these connect. And so finally, we could say angle 1 plus angle 14 is 180 through transit. So if there was another step after this proof, after where we left off, I would say this line. And why? We could say transitivity, or you could say substitution. They're basically the same. Transitive property or substitute. Same thing. And then since we've shown that they're equal to 180, we could say angle 1 and angle 14 are supplementary. Definition of supplementary angles. Okay. Any questions, comments, concerns? I hear someone's mic on. No big deal. If there is a question, please let me know. Anthony, you might not have meant to have your mic on. Maybe you did. Do me a favor and just click that off for me if you don't have any questions. If you do, it's all good. I want to hear from you. Okay, it's already 10:30. I'd like to still do one more with you guys. And then I want you all to try the mastery test on your own right now with me. So let's do this one as a group. So they give us this figure at the top, and then they are telling us in the figure, AB is parallel to CD. This is like our given. It doesn't say the word given, but it's telling us in the figure this information. So that is like a code basically for given. In the figure, this is true. AB is parallel to CD. So line AB, the two horizontal lines are parallel here. And then what do you see? We see some crossing lines going through the two parallels. Those are both acting like transversals. So these two diagonals are both transversals here. And in the chat, I've got a comment. What is the name? Anaya asked what the name of this mastery test is. Let's see. Beginning. Lines, angles, and mathematical proofs. I think it's our first one in Unit 8. Before you start, though, check this one out with me. It's not saying that we need to, it's not telling us like the final proof they want us to do. What I'm seeing is these are drop downs that I expanded and cut and pasted in. So we're supposed to pick one item from the first box and one item from the second. So let's just see what we can reason out here. Angle AEB and angle CED are congruent. Why? Angle AEB, that's this one, and angle CED. So that's this lower one, but it's a larger triangle, but we're not concerned about the triangle, it's just the angle. So they're saying these two angles are congruent. Why? Are they linear pairs? So we have to pick one of these. Are they linear pairs? Are they vertical? Or are those two angles corresponding? So which one of those reasons makes the most sense for this diagram for saying that those two angles that I marked purple here are congruent? Can anyone take a risk and answer this one? Best thoughts. Are those linear pairs, vertical angles, or are they corresponding? Here they are. I'm going to kind of draw it cleaner on the right side. These two angles. So this is like kind of testing us on the definitions. So if we can identify what type of angles these are together, linear pair, vertical, or corresponding. Then we would be able to answer that first box. Should we review really quick what those three different types of angles are? Okay, we will review. Vertical angles are opposite angles. So this set in this problem are vertical because angle AEB and angle CED are like directly across the point from each other. This point of crossing, the E point. One's on top, one's on the bottom. They're across from each other. So those are verticals. Vertical angles are opposite or across from each other. Okay. Corresponding angles are when they're in the same position. And in order to have corresponding angles, we have to have the two parallel lines like this, and then a transversal. So in this case, angle 1 and angle 5 down here are corresponding. Correspond means like go together. And that's kind of generic, but these, I guess I think about it as they go together because they're in the same placement, the same position relative to each other. And then the last one they asked us about was linear pair. Remember, linear pair means they're forming a straight line. So it's two angles that together are forming a straight line, like these two. Angle 3 and angle 4 in this diagram are a linear pair. If you don't have these in your notes, now's a good time to put these three diagrams in because it's a good visual explanation. I think it's a good one for each of these different definitions, okay? Also, vertical angles on the left, these are congruent. So if we ever have two vertical angles, they're congruent together. Corresponding angles are also congruent together. But linear pairs are not congruent, they are supplementary. That means they add to 180. So there's three different types of angles that we're going to be using all the time. Vertical angles, corresponding, and linear pair. Okay, I'm going to go back to that question now. So we were here. So for the first choice, we would want to choose vertical because the two angles they described are vertical angles. Angle AEB and angle CED, this top and this bottom one across from it, they're saying they're congruent. Why? Because they're vertical angles. So this is kind of like a statement and a reason. We just chose the reason. For the last part, it says angle AEC and something else from the drop-down box are congruent by vertical angles theorem. So what's vertical to AEC? What is the angle that's across from or opposite of angle AEC this time? Angle A to E to C. That's this one, the red one I just marked. Can anyone tell me in the chat what angle is vertical to AEC? Vertical means across from. Any ideas?
I'm pretty sure it's the corresponding.
Well, okay, Levi, let me think here. So not corresponding this time. Corresponding would be like in the same place relative to the two parallel lines. So here in red, Levi, and everybody, here's two parallel red lines. And then if I make a new one that's cutting across of them, I'll make it blue so it looks different. So here's our transversal, boom. Because we have two parallel lines in the blue transversal, in this scenario, it creates 8 angles. I'm just going to label them 1, 2, 3, 4, and then 5, 6, 7, 8. Correspondings that you mentioned are the ones that are in the same placement. So for example, looking at 1, 2, 3, and 4, if I chose 4, if I singled out angle 4, it's on the bottom of the 1, 2, 3, 4 angles, right? What's on the bottom of the other set of angles, the 5, 6, 7, 8? This one. It's labeled as 8 in this picture. So we could say angle 4 and angle 8 in my new picture are corresponding. And there's more, like angle 3 is on the right, and what's on the right below it? Angle 7. So we could also say angle 3 and angle 7 are corresponding. So there are corresponding angles in this diagram that they gave us, but they're mentioning specifically for that last question, they're mentioning vertical angles again. So we basically answered vertical for the first question, and now they're telling us angle AEC and something else from the box right here are vertical angles. They're congruent by the vertical angles theorem. So we want to identify the first one that they told us, AEC, and I'm going to show you guys in blue now the one that's opposite it right here. When we say vertical, we mean they're like across from each other. So now it's a question of how do we name that blue angle I drew in? We can name it two ways. You just have to pick one of the points and then move towards the center and then towards the other side. So we can name this angle BED from this side, B to E to D. Or we can name it in the reverse order, angle DEB, bed or deb. In this case, angle BED or angle DEB. They're the same thing. And we look below and we're like, okay, cool. One of them does match BED. If it had been listed as DEB, that's okay too. It is confusing, or could be, because they do mean the same thing, and there's two different ways to name an angle. So Levi, thank you for jumping in there, and Victor, and Savannah. Nice job, Savannah. You got it. Angle BED is vertical. Thank you all three for jumping in there. All right. With 20 minutes left, I'm wondering if time would be best served for you. Would you like me to do more questions with you like we've been doing? Or would people like to break off and try doing the test on their own at this point? What would you guys like to do? I'm open to either. I can do more examples that you can have in your notes, or you can have some independent time to try it on your own. And then I'm here as a resource if you want to do it with me and get help. Okay, Xavier, you ready to go? Okay. How about the rest of you? What would anyone else like to do? Should we just break off and start doing this independently, or would you like to do more examples with me now without doing it independently? Oh, there's some chats. Stay, okay. Well, good. Okay, it's about half and half for people who are responding. So here's what I'm going to say. We've got 15 minutes left officially in class, or a little more than 15. So I want those of you who feel ready to go ahead and start this mastery test. It is called like lines, angles, and mathematical proofs. Here it is: lines, angles, and mathematical proofs. I think it's the first one in Unit 8. Now, the rest of you, go ahead and stay in. I want all of you to stay in the call, please. But if you're going to work on it on your own, that's fine. Otherwise, stay with me in this call. We're going to do a few more examples until 11 o'clock. However, I am going to officially assign this test to all of you as homework today. So our homework today is to do this lines, angles, and math proofs. I want you to all try it today after class is over, okay? Or right now if you're going to start now. It's okay if you don't pass it on the first try. This is a learning experience, right? So just do your best. And if you need to retake it or take it with me again, maybe tomorrow at 3 o'clock for the tutoring hour, then that's all good, and we'll do it together, okay? All right, so with that all said, let's jump in to this question. Here's one where they're not giving us a picture, and I didn't put in the drop down. So you know what? I'm going to have to skip this one for now. Sorry about that. I need the drop downs to know what is invalid. So let's do the next one. Oh, there they are. Cool. All right, so actually I did put them in. So here's our first drop down box, and let's see what they're saying. Line AB is congruent to line segment CD. Point P is the midpoint of AB. So I'm going to draw that to get an idea of what's happening. Here's AB. And then they said point P is the midpoint. So right in the middle is P. Then they said point Q is the midpoint of CD. So let's put in our CD. It doesn't say CD and AB are touching, right? Or crossing. Maybe they are, but I don't think we can assume it. So we're just going to draw them separately. It does say that they're equal though, right? Congruent. So AB and CD are congruent. Now we've got some midpoints they're telling us about. Q is the midpoint of CD. Okay, now third sentence above. Point R is the midpoint of AP. So cutting AP in half is R. And continuing, point S is the midpoint of QD. Right here, point S. Then they want us to pick an invalid relation from the list. So invalid means not true, right? Incorrect. So we have to figure one of these 5 statements from this first drop-down box is incorrect. The rest should be true. So let's see what we can figure out. the first I'm going to number these 1, 2, 3, 4, and 5. So line 1, segment QD is congruent to segment AP. Is that true or not true? QD and AP. What do you guys think? Is that true or not true? Can we say anything on that?
I think it's true.
I think it's true also, Levi. Let's think about for a quick second why. Why is that true? I think you're right. I think it's true also. We know that the whole segments are equal. They told us that at the beginning. Remember back at the top? So we know like AB, CD are congruent segments. Then they start cutting things in half. And they say P is the midpoint and Q is the midpoint. So that means since we've established that the whole segments are equal, and now we've got midpoints in here, that means AP, that's half of the first segment, and QD, well, that's half of the second segment, right? It shouldn't matter that one's on the left and one's on the right. We know that we've cut them in half. So I think because of that, we can say statement 1 is true. Now, I know that they didn't ask for all those reasons, but I want to be sure, just like when we're doing our proofs, be sure that we're thinking about our reasoning, our evidence. And that's what I was doing, is want to make sure I know why I'm thinking it's true. I just want you guys to practice doing that as well at home. Okay, let's look at line 2. Line 2, PB is congruent to QC. PB congruent to QC. I just drew those in red. I think that's also true, right? Why? PB is half of AB and QC is half of the other one. And because the wholes are congruent, the halves are congruent. So I think that's also true for the same reason as the first. Line 3, segment QD is congruent to segment PB. QD, PB. Again, I think those are true. Same logic as before. The halves will equal since the wholes are equal. Segment AP is congruent to PQ. Oh, this is it probably. This is a weird one. Look at line 4. Segment AP is congruent to PQ. Do we know anything about PQ? We don't know where these two lines are actually placed, right? They could be anywhere. So they're now connecting P to Q. And that's the first time that they've mentioned like any of the points that are on the different lines, but together. PQ, we don't know how long that is. It could be anywhere. It could be 100 feet or 2 inches, or they could be the same point for all we know. Just labeled differently. So statement 4 is our invalid false one. How do we know? Because we don't know anything about PQ. So we can't make any statements about it and its length. Let's check out the second one. We have time for that. So now continuing above, because point R is the midpoint of AP and point S is the midpoint of QD, okay, we can conclude that what? Let's look at the options. Here they are. So we'll label these and we'll have to go through them. And this time it's like one will be correct, the rest are incorrect. And we're picking the one correct one. Segment RP is congruent to CS. RP CS. This is why I'm drawing pictures of when they don't give us a diagram or a figure, it's important to draw a picture. All these letters can get confusing. I mean, it's confusing for me too, believe me. That's why I'm drawing a picture so I can help myself like keep track of what we know. RP is a quarter of AB, right? RP is a quarter. It's half of a half. CS is not a quarter. CS is 3/4. It's a half plus a quarter. So we can tell visually because we know that much about these two figures. RP is a quarter, and CS is like a whole half plus a quarter, so it's 3/4. We know those aren't congruent. This is false. The picture helped me see that right away. And we can assume that because we know like it's been halved and halved again, creating those little sections. Statement 2, segment RB is congruent to CS. RB, I just drew it again at the top, RB, and then CS, that's the same one from the last one. This time, I think this is true. How do we know? Well, RB is a quarter chunk plus the half chunk. What is CS? It's a half chunk plus a quarter chunk. So because of how they frame this and how we like cut the two segments in half and then cut those in half again, we do know that these chunks are equal. So statement 2 is true. Let's see. Rather than look at the next 3 statements here, because we found the true one, let's look at a new problem, a new question. Okay, let's do this one together. This is a good question because it has parallel lines and transversals. So there will be corresponding angles, there will be vertical angles, there'll be all sorts of stuff. I put our drop-down boxes there. So here's the first drop-down. I'm going to wait on that. So let's read through what they got. And it's in a paragraph proof, which, you know, is frustrating because it's like hard to read it and keep track of it. It makes more sense to say it and to talk about it human to human, but I think it's harder to kind of keep it together. So let's do it together. It is given that angle EIJ is congruent to GJI. I'm going to mark those. EIJ is right here. GJI is right here. It is given that those are congruent. And if I look above, they did say that at the very top of the screen. Those two angles are congruent. They also said that the two lines are parallel. So AB and CD are parallels. Okay. Uh-oh, I'm losing people. Also, angle EIJ and IKL are congruent. EIJ and IKL, let's mark that. GJI and JLK. JLK, that's right here. So these are congruent together because they're corresponding. And it says that in the line, as they are corresponding angles for parallel lines cut by a transversal. So the two pairs of angles that are top and bottom of each other are congruent. And it was stated at the beginning that these are congruent. So that means all 4 of these guys so far are congruent angles. By the definition of congruent, the measure of EIJ is equal to the measure of GJI. And these are all equal to each other. So measure of IKL and measure of JLK are equal, and the angles are congruent by symmetric substitution or subtraction property. What they're doing here is the transitivity. that I talked to you guys about earlier. So it's basically substitution. Remember, substitution and transitive are basically the same thing. They're taking a string of true statements and substituting in or linking them together in a new way. They're saying EIJ is equal to GJI, and then we get EIJ equal to IKL. I'm looking down here in the middle of our paragraph proof. And then we get GJI equals JLK. And then they do like a summary. So IKL is equal to JLK. Why? Well, look, we plugged this into that, and then we plugged this into that. So they did like two substitutions, and they basically said IKL is equal to JLK. It's basically like saying like X is equal to Y is equal to Z, so X is equal to Z. So this first one is substitution, or they could have said transitivity, and that would be okay too. Okay, angle JLK and JLD are supplementary angles. JLK, JLD are supplementary angles because they're forming a straight line. Remember, straight line. These two, I'll fill them in, are forming that KD line or CD line on the bottom. So they're supplementary because they're linear pairs. Linear pair theorem. And then lastly, for the third drop-down box, by the something theorem, the measure of IKL plus JLD is 180. IKL and JLD. So what they're doing is taking this information, JLK plus JLD is 180, and then we're going to substitute in JLK where we see it below. So we could say IKL plus JLD is 180. That's what they have here. But why are we doing that? It should be more substitution or transitivity. There it is. So that was another option again. So we use substitution twice this time. That's okay. We do substitution all the time in our math, and that's what. So there's the whole proof, and we needed to use substitution and then linear pairs and then substitution again to be able to say that these two angles are supplementary and added to 180 together, even though they're not like touching and forming a straight line together. Okay, folks, I've got down the attendance. If anyone would like to stick around and ask any questions, you're free to do so. Otherwise, you're free to go.